Hi, I'm Linda McClellan from Bristol Myers Squibb. I'm the Director of SAP Technologies, and along with Raj Bhatt, a Senior SAP Consultant from AWS, we'll be discussing the SAP transformation and GXP compliance for Bristol Myers Squibb. As part of our agenda, we'll be going through just a small introduction to the BMS as a company. We will also be looking at the SAP HANA transformation objectives, our global compliance requirements around qualification and verification, benefits that we realized from the project, as well as lessons learned, our future plans, the deployment with SAP Framework and AWS architecture. So Bristol Myers Squibb is a biopharma company, and our mission is to discover, develop, and deliver innovative medicines that help patients prevail over serious diseases. Our overall vision is to be the world's leading biopharma company that transforms patients' lives through science. Bristol Myers Squibb utilizes SAP software in combination with business-driven policies, directives, and standard operating procedures to provide a total solution in managing key processes such as supply chain, orders to cash, procurement, finance, manufacturing, warehouse management, through the life cycle of our medicine. There are several factors that we considered in the moving from on-prem to AWS. The first one was around just the life cycle of our SAP instance, our ECC instance in particular. The life cycle of that box would be running at end of life in 2025. Now, we started looking at this in 2017. 8 years may not seem like a long time, but it actually isn't a long time at all in SAP time. We also looked at the hardware that our SAP instances were sitting on-premise. They were at end of life also. So it would cost us a big chunk of money to replace all of our SAP instances and keep them on ECC. The second factor was around business processes. Our business was coming to us saying, we saw this really cool thing in SAP, and they said, we need to be on S4. And we said, in order for us to get to S4, we're going to have to purchase HANA appliances, which are very expensive for on-premise. So our business was really disappointed that we couldn't give them the functionality that they wanted when they wanted it. Our third factor was around our executive team. They were really looking at why can't we go to the cloud? So they created a cloud-first initiative, which was we're going to the cloud, figure out how to go to the cloud, and if we can't, we need to have a very good reason why we can't go to the cloud. One of the other items we had in consideration was our GXP compliance. Our SAP systems are GXP, so there's qualification and verification requiring around all processes of those SAP instances. So we had to look at the qualification processes for the infrastructure, the databases, the operating systems, just something simple as backup and recovery, ensuring that there was controls around that while moving into Amazon. We also looked at the different flavors of our SAP instances. We looked at high availability in our disaster recovery solutions also. So everything had to be changed from the qualification processes because we were on-prem. On-prem qualification is not the same as cloud qualification, and we didn't really have that experience at Bristol Myers for the validated environments. We also had to look at the validation processes for the tools that we were using. Now, we validated several of these tools already, such as the SumDMO, the SAP export and import, and the software upgrades themselves, but we didn't have them validated for a migration into AWS. So we had to go back, work with our quality team, and redo these whole processes. We also had a new tool from SAP called Near Zero Downtime, which allowed us to minimize our downtime for our S4 migration. That was something that we used similar tools in the past, but this was specifically for S4, and that had to be qualified, as well as the data verification processes around the financial tables, as they were going from a very large number of tables down to one table. We had to ensure that data in Table A made it to the equivalent of Table A in S4. So our timeline went from early 2018 to February of 2020. And starting in the spring and the summer of 2018 and 2019, we started looking at what should we do for the VPCs? How do we build VPCs? What kind of VPCs? Where are we going to put them? What availability zone? What region? How many servers would we need? You know, just doing the whole concept of what you do in the beginning of AWS migration. We looked at the automative processes. How do we automate this? How do we deploy our servers consistently in an automated fashion? We brought in our quality team very early. They were very appreciative we brought them in early. They worked hand in hand with us through this whole process. Towards the end of 2018 and beginning of 2019, we started deploying sandboxes. So we deployed our sandboxes, we did our migrations, and then we started working on our development systems. Started doing the migrations for our development systems. And then at the same time, we were working on our templates for the deployments. We were looking at our regulatory risk assessments for going into AWS. Once again, if you're an on-premise solution, you own the network. When you move to AWS, you don't necessarily own the network. You have to work with AWS to secure the network. We started looking at our high availability solutions. And then during the course of 2019, we started deploying our test systems, our support landscape, and then our production instances. Meanwhile, we're also doing mock upgrades and then looking at high availability, looking at our backup and recovery solutions, looking at disaster recovery until our cutover in February of 2020. And as you can see from the slide, we deployed more than 225 SAP servers during this process. So our end results and what we benefited from this was using AWS. They had the servers available in the availability zones. We didn't have to say, oh, I'm going to go out, I got to procure servers, I have to qualify the servers, I have to install the OS, I have to install the databases, I have to install the SAP instances, which would take weeks to get done. Using AWS as our solution, we could go out with our templates, deploy a server within hours. We engaged the quality team very early. It was probably one of the best things we did was engage that team early because of the regulations around our environments. We had a 90% reduction in effort for the provisioning of the servers based on just using AWS, which cut our costs almost by 2/3. We had a 50% reduction in the documentation needed for the OS and database provisioning, and then also with the SAP instances. Once again, repeatability process, reduction in defects through the automation process. It was really a lifesaver for us, and it saved us a lot of time and costs. Also, as part of this process, not necessarily AWS related, but we also used the HPALM tools in order to digitize our test scripts. Once again, validation was very happy about that. So in this whole process, it freed up our SAP migration team to do things like fine-tune the upgrade, look at ways to reduce our downtime, run mocks so that we would have the process down to exactly where we knew we had to stop and make changes. If we were deploying servers on-prem, the time that we were spending doing mocks, we would be doing deploying servers. And then 4 months after we went live, AWS came in and said, let's do a capacity realization check for you. So what we did was we let SAP come in and with AWS. They looked at our capacity, and we found that we were able to save 20% of our costs just in 4 months of deployment. So lessons learned from this, and highlights from our lessons learned are we were able to reduce our timeline because of AWS. They had the servers ready for us to go. All we had to do was pick and choose what we wanted, throw them into our templates, adjust our parameters, and we were deploying instances. It was, once again, it was cut our timeline down, I say, by months. We were also able to look at our high availability and disaster recovery solutions as part of our QA migration. We were able to use live users who were testing as our guinea pigs to test high availability. We could, we let them know, hey, we're planning on doing a failover. Let us know if you see anything. Once we were done with the high availability testing and disaster recovery testing, we were able to shut those servers down, and then we stopped paying for them, which is, amazing. On premise, you bought them, you own them, right? As another item was that when we deployed our servers, we deployed them as we would on premise. So if we had a 16 by 32 on-prem, we deployed a 16 by 32 in AWS. Once we went through and we had everything deployed, we were able to go back and look at the capacity and the workload that those servers were actually utilizing and say, hey, we can change the server type for this. We don't need a 16 by 32. We could cut it in half, or we can deploy an extra one because it is overutilized. We were also able to claim temporary storage. Now on-prem, once you bought the storage, you own the storage, right? In AWS, we were able to say, I needed 500 gig to do the upgrades. Now I only need 10 gigs, so we get, 490 gigs back. Also, one of the really wonderful things was that we engaged the AWS ProServe team very early in our process. The ProServe team came in. They helped us with the innovation and solutions that we needed in order for the project to be successful. They helped us design high availability for SAP ASE databases. No one was doing that. We were one of the first companies to have high availability for ASE. We were also had to design high availability for a scale-up S4 instance. We had to design high availability for and disaster recovery replication so that if there was a failover, we weren't automatically going to DR. We were failing over correctly. So AWS would, go out and say, hey, let me go work on this at my lab. They would go work on it at their lab. They come back and they say, hey, we got a solution. You want to look at it? And we would look at it with them. And they were very helpful through this whole process. And another thing that was very helpful was that we were able to take our technical staff, have them work with the AWS team for training and KT. So BMS has been using AWS for years, but not in the SAP world. So our SAP technical staff didn't really have the expertise in AWS. And it was great that the ProServe team came and worked with our team and, got them to the point where, they were able to do a lot of things on their own, before we even got to the test systems. It was very helpful for us. As part of this initiative, we're moving to S4 because we knew that there were business functions that we wanted to bring into place. But from the technical side, we also knew that there were other items that we'd like to also utilize from, like I said, from a technical side of the house. There was another item that came up, which no one knew about until the fourth quarter of 2019, was that BMS and Celgene Pharmaceuticals were merging. And with that merger, we knew that there would be thousands of SAP users that would need to be created sometime in 20 and 21. We also knew that we would have to start migrating the legacy systems from Celgene into S4. Being in Amazon was a lifesaver for us because we were able to say we can scale to absorb the data, to absorb the users, and make our SAP instances, like I said, scalable for the influx of data and the influx of users. One of the other really cool initiatives that we had with AWS was, okay, we're here, now what else can we do, right? So one of the items that we're looking at is reducing the amount of time it takes for us to do our monthly refreshes from production to test. We do these every month. It usually takes us about 3 to 5 days to do them, and our business waits 3 to 5 days to start testing again. So with AWS, we're looking at ways to take it from days to hours. We're looking at a scale-out solution for HANA, a scale-up solution for HANA, as well as the ASE NetWeaver database solutions. We're also looking at automating our start and stop scheduling of our SAP instances for non-production. We have already implemented stopping and starting of our sandboxes, which, on-prem, you look at it and go, do we really need to do this? We've already bought the hardware. It doesn't really save us any money shutting them down. But in Amazon, it does save you money shutting them down, right? If you don't run your sandboxes on the weekends, you save whatever the computing power is for the weekends. So now we're going back and we're talking to our development teams and our configuration team saying, hey, which systems can we shut down on the weekends or shut down in the evenings to save us some money. We're also looking at auto-scaling and predictive auto-scaling. So let's say month end, right? We find that we have peaks during the end of the month due to month-end processing. That could be a predictive way of rolling out an additional couple application servers, right, on the SAP S4 system. And then at the end of month end, we gradually and gracefully shut those systems down. We could also look at our system. You say our system runs at, let's say, 70% capacity. If it hits 85% capacity, we roll in another application server, right, to bring the capacity down. And then once we get back down to 75% capacity, we could take that application server out. Those are some items that we're looking at, and hopefully in 2021, we'll be able to implement them. So I'm going to turn this over to Rajbhat, and he will continue on with the rest of the presentation. Thank you.
Thank you so much, Linda. Hello, everyone. I'm Raj Bhatt. I'm a senior SAP consultant at AWS and have been assisting BMS from almost 3.5 years now with the various SAP on AWS projects. And I'm very excited to share the GXP compliance automation solution that BMS have actually built as part of the migration, and they're still using it as part of their day-to-day activities on AWS. Before we get into the compliance approach, I would like to share a reference architecture diagram around how BMS is actually leveraging different AWS services to support their different SAP application. So if you look at the bottom layer is the database layer, which is set up using 3-tier HANA system replication. They have 2 regions. Their primary region is actually built using multiple availability zones. Their SAP application is actually running on a multiple availability zone. And they have a HANA system replication set up between the databases. On the application layer, they also have a high availability solution which is built upon a Red Hat clustering technology to protect against any failure related to an NQ server or a message server failures. From the database perspective, they are using various type of EC2 instances. To just start with a 12 terabyte HANA instance, which is a high memory instance family that is being used for S4. And also they're using X1, X1Es to support their SAP BW application HANA databases, which are actually deployed in a scale out manner. They are using R5 memory instance family for SAP ASE databases, and M5 and C5 product families for application server needs. So any systems that are not deployed with high availability that are actually protected using an EC2 auto recovery feature. So for an example, from SAP perspective, the dialog instances or web dispatcher or even SAP SAP router, those instances are actually having those EC2 auto recovery feature enabled. So in case of any unplanned outages, the underlying EC2 instance will recover by itself without any manual intervention. So to connect this SAP application outside of this VPC, BMS is actually leveraging network load balancer, which actually serves a purpose whenever any application, whether it's an SAP or non-SAP, wants to connect to this highly available SAP instance outside of the VPC, network load balancer will actually identify where the primary system is running, whether it's a ASCS primary database or a primary database. Sorry. Along with this core components of SAP for deploying the SAP systems, BMS is also using S3, which is actually storing the backups. So any backup needs are actually being uploaded to S3 bucket, and that S3 bucket is actually replicating to another region, which is their DR region, to support any DR needs. The tertiary HANA database, whether it's a HANA or ASC database, is also being replicated using async mode. So that's how BMS is actively keeping their DR side up to date with their live transactions. So there are a lot of things, a lot of components that we have to build to support various type of SAP systems. And if we put the compliance on top of it, we are talking about several IQ documentations and several validation processes that needs to be done. It's a major area for any SAP customers. So let's talk about how this entire solution came into life. So as we know from GXP compliance point of view, one of the major steps is actually doing the qualification for infrastructure and the SAP application. Traditionally, in on-prem world, it starts with procuring the hardware, installing and configuring the SAP application, the operating system, and the database. So although there is a process defined, but it actually lacks the ability to scale according to the future demand. And that's where BMS simplified this task by leveraging SAP deployment framework, which provides a repeatable, scalable, and consistent process for deploying SAP solutions on AWS. So let's talk about the infrastructure piece a little bit in more details. So in terms of qualification, the infrastructure qualifications process on AWS starts with just reviewing the SOC 2 reports that are provided via AWS Artifact service. So this service actually offers a readily available reports that are actually developed and provided by third-party auditing group on an annual basis. And also, most of the frequently used AWS services to launch an SAP systems are actually part of this SOC 3 report. So while their quality team was reviewing how they would do the infrastructure qualification for this various SAP on various AWS services, they actually relied on this SOC 3 report to carry forward the qualification needs. So just by leveraging that, they actually reduce a lot of time and effort that it takes to qualify the infrastructure piece. And let's talk about the application piece now. AWS CloudFormation service is the heart of the solution, and CloudFormation templates describes your desired resources and their dependencies, so you can launch and configure them as a stack. Uh, the CloudFormation templates offers a lot of parameter-driven input values. In terms of SAP, those values could be the size of the database that you would like to deploy, the type of EC2 instance that you want to select, as well as the instance IDs that you want to pick up for your SAP installation. Along with that, you can actually impose a strict controls in terms of parameter selections, which actually enables you to reduce the amount of human errors even before the systems is getting deployed. Other services that we have used is the SSM parameter store, which is actually storing the encrypted password that SAP system would be using for during the installation. And Lambda functions are used to calculate the exact size of the EBS volumes that supports the database file systems for ASC or HANA database. So these are a lot of components that actually that's where the SAP deployment framework is built around. But by parameterizing this entire solution, along with creating multiple templates, as a matter of fact, 15 templates that BMS actually have deployed, they were able to deploy around 55 unique combination of different SAP solutions automatically from starting to end. Which not only saved the time and efforts that it takes to deploy an SAP system, but it actually brought a lot of consistency, repeatability, and scalability in terms of deploying the SAP systems, which are ready for doing the actual migration. Within the CloudFormation, of course, there are two major service components that actually is used for SAP for building the SAP systems. One of them is CFN init, and the second one is CFN signal. These two helper functions actually really helped BMS in terms of doing the integration from AWS perspective and doing the SAP install. So CFN init, for example, it actually initiates it actually looks into the AWS CloudFormation metadata and performs those tasks on the EC2 instance level. So in terms of SAP, it can install packages that are required for running an SAP system at the OS level. It can actually enable services at the OS level or disable them if you have a compliance requirement, and also trigger a script that is sitting on the operating system as well. The CFN signal actually is being used to notify the CloudFormation stack as an event if there is an error during the installation. So right even before the SAP system gets into the migration, we are able to identify any potential defects as part of the installation. And the actual logic, of course, to install these SAP systems are actually bash scripts, which are built for various AWS operating system and the database installation processes. And we are using SAP standard tools to do the actual installation. So software provisioning manager is the tool. And let's talk about the evidence, right? So, of course, by qualifying not the systems but the templates, these templates needs to be qualified once, and by qualifying these templates, BMS significantly reduced the amount of efforts that it takes to create installation qualification documents for individual systems. So rather than qualifying individual systems, they qualified the templates and put those templates in their own internal code repositories to follow their standard change control process. You don't really need a lot of evidence now because your evidence is actually your code, the infrastructure as a code. But just in case if we end up rebuilding the system from a snapshot or launching an AMI snapshot for building another EC2 instance, you do need some kind of an evidence around how the system was built before, and what was the AMI ID that we have selected while we were building this system. So the SAP deployment framework solution that BMS is actually have built generates a log file for each and every SAP system deployment. And that log file has all the relevant information, including the timestamp, the type of SAP systems that were built, and overall health check status for those deployment that has been done. So as we can see here, there are the database installation evidence, so we can exactly know when the database was installed. We can also ensure that it actually passed certain checks. So if we restart a database, did all the services came back healthy or not? And the same checks were also performed at the various other SAP applications, whether it's an ASC database or an SAP application instances. So this is how overall BMS is actually have automated their entire SAP system build, including supporting their compliance needs around installation qualification process. So if you want to learn more about our other AWS customers, how they are using, how they are running SAP workloads on AWS, please feel free to join the other breakout sessions from our customers, Newmont, Zalando, and Volkswagen. And we would like to thank you so much for joining this session to learn how BMS actually have automated their GXP compliance need as part of their SAP solution. SAP solution on AWS. Again, thank you so much, and please do this survey. That really helps us to serve you better in future. And thank you again for your time.